Quadratic functions in context. We're going to turn to the world of sport, and we're looking at the ski jump championships. We have a skier who is entering the competition looking to win this, and they gain points based on the maximum height and the maximum time in the air. So our skier transcends down a steep slope, reaches a ramp here, and then momentum carries them up the ramp, and then they leave the ramp and follow a parabola in the air before landing. Now this parabola can be described by the equation h equals 24 plus 10t minus t squared, where h is in meters and t is the time in seconds. So first of all, let us calculate the time that the skier was in the air. So how long were they airborne for? So if you have a look, the equation describes the height at each point for each given time. And when the height is 0 meters, that's when the skier lands, and that gives us the total time. So we're going to set this equation to equal 0. And then we can put the 0 on the other side of the equal sign. Now because we've got minus t squared, we want to have this as the leading term. So we'll just rearrange this and swap the t minus t squared and 24 around. Now we've got minus t squared plus 10t plus 24 equals 0. Now we're going to factorize this. So we can factor out the negative there. And now we can factorize the brackets. So we're going to have two brackets with a t as leading term in each one. And now we need two numbers, the factors of minus 24, that add up to give minus 10. So factors of 24 would be 12 and 2. And now we need to figure out what are the signs of these factors. In the first bracket we're going to have t minus 12, and in the second bracket we're going to have t plus 2. So therefore in the first bracket, for this to equal 0, t must equal 12. In the second bracket, for this to equal 0, t must equal minus 2. So we've got two solutions. We have t1 at 12 seconds, t2 at minus 2 seconds. Now at t2 minus 2 seconds, this would suggest that the skier has done a bit of time travel and gone back 2 seconds in the past. Not possible, so we'll discount this one. So therefore the solution must be t1, 12 seconds. So the skier is airborne for 12 seconds. Now we can calculate the maximum height. And at what point in time does this occur? Now if you have a look at this, the maximum height occurs at the peak of this parabola, and this is the turning point, which occurs at the axis of symmetry. So we've got turning point and axis of symmetry. This is a complete in the square type of question. So let's take our function and we'll just rearrange it so we've got the t squared term leading. Now we've got negative t squared, so the completing the square formula is going to be q minus t minus p all squared. And we look for the values of minus p and q because they give us the turning point, which will give us the maximum height and the time. So let's first of all calculate p. So p is going to be half of the coefficient of t, which is 10 over 2, so p is equal to 5. So if we first of all square 5, 25, but this is being multiplied by minus 1, so it'll be minus 25. But we want positive 24. So we have to calculate what do we have to then add or subtract to this to give us 24 from minus 25. To do that, we take the 24 and we subtract minus 25. So it'll be 24 plus 25, which is 49. So q is 49. And now we have our turning point at minus p, which is minus 5, which is positive 5. And we have q, which is 49. So the turning point occurs at 5 seconds and it's at a height of 49 meters. So we've got 49 meters is the maximum height the skier jumps, and this occurs when t is equal to 5 seconds.